Hello. Good afternoon, everyone.
Ahmet Hocam canlı yayın başladı. Başlayabilirsiniz.
Hello, good afternoon, everyone. Today we are going to continue with the afternoon session right now. This is session 22, and we are waiting for our first presenter. I'm planning to wait additional 2 minutes, and then if he or she is going to be late, we can continue with Diane, which is the third presenter, and then continuously, when the first presenter arrives, he can make his presentation. Okay. Diane, are you there? Diane, can you hear me? Diane, Lydia, can you hear me? If you can hear me, just please let me know, or you can write down through the chat.
Ahmet Hocam birinci sunumun girdi şu anda.
Geldi mi? Tamam.
Geldi hocam.
Tamam, teşekkür ederim Sümeyye Hocam. Okay, now we are going to start with the first presenter, and I would like to welcome the Dr. Souley Harouna. Harouna, if I am
Yes,
wrong,
yes.
please.
I'm Dr. Harouna Souley from Mining College of Niger, Niamey.
Welcome. Can you share your presentation with us, please?
My presentation?
Yes.
It's okay. Yes. My presentation is like a physical-chemical evaluation of groundwater.
Okay.
Yes. Groundwater characteristic in like arid zone.
Okay.
Can I have in which place I can? Oh, yes.
Let me announce you first.
Okay.
Now we are going to listen Harouna Souley with the physical-chemical evaluation of the groundwater quality in urban and rural areas of the Agadez region, northern Niger. So please share your presentation and start with your presentation.
Thank you very much. Okay, I show my presentation.
Can you convert it to the full screen on the downside?
First screen. Okay, it's okay.
Yeah, it's great. Thank you very much.
Yes. Donc, so my presentation is on physical-chemical evaluation of groundwater quality in urban and rural areas of the Agadez region, northern Niger. Presentation outline is like 4 areas, donc an introduction, materials and methods, result and discussion and conclusion. So as the introduction, I say that groundwater is the main sources of drinking water in the Agadez region in Niger, where surface water is scarce. However, its quality is increasingly threatened by human activities such as agriculture, poor sanitation, and rapid urban growth, raising concern about its safety for consumption. This study evaluated the physicochemical quality of groundwater in 4 communes: Agadez, Bugram, Dabaga, and Ingal. This is the region in Niger. By analyzing case parameters and comparing them with WHO standards, the result reveal localized contamination, particularly with nitrate, fluoride, and iron in some cities, indicating both natural and anthropogenic influences. Overall, while many water samples remain within accepted limits, several exceed guideline values, heighten potential health risk. Could the need for regular the need for regular monitoring and improving groundwater management in the region. So research problem is groundwater in the Agadez region. The main sources of drinking water is increasingly at risk of contamination due to human activity and limited monitoring, raising concern about its safety. General objective is to assess the physico-chemical quality of groundwater in select areas of the Agadez region in relation to WHO standards. Our specific objective is to analyze groundwater quality, compare if with WHO standards identify contamination, and evaluate the impact of human activities on water quality. With which material we can make this study? Donc, you use the material to sampling, position, GPS, and material to pH measurement. The study is organized into 4 main steps. Donc, 4 steps. First step, literature review, water sampling, and the study site is second step, and laboratory analysis of physico-chemical parameters in the collected water samples. Processing and interpretation of the obtained result is the main step. With water sampling, groundwater samples were collected from wells and borehole distributed across the select communes. A total of 30 samples were collected, 7 from Agadez, 7 from Bugram, and 8 Dabaga, 8 from Ingal. Sampling location were selected to provide a comprehensive spatial representation of groundwater quality in the region. Water samples were collected in clean polyethylene and glass bottle, following standard sampling procedure. The volume of each sample ranged between 2 and 5 liters, which was sufficient for complete physico-chemical analysis. Laboratory physical analysis of water samples, you can see the materials, measurement of pH, and other physical chemical parameter, pH, conductivity, and waterability is we see the materials. Water samples were preserved at 4 degrees and transported to the laboratory within 48 hours after collection. 48 hours. The analysis focused on major and minor ions, anion, H, and cation, as well as total iron. Ion determination was performed using standard water methods like colorimetry or selected ions and metry for trace elements such as iron and nitrate. Sodium and potassium were measured using flame photometry. Calcium, total alkalinity, and total hardness were determined by trimetric methods. Magnesium and bicarbonate concentration were indirectly calculated from hardness, calcium, and alkalinity result. Data processing, descriptive statistic, and correlation analysis you use to summarize the data and identify relationship between physico-chemical variable in order to understand the main factors controlling groundwater chemistry. HWO drinking water green lines is used to evaluate the sustainability of groundwater for human consumption by comparing measurement parameters with international quality standard.
Doctor, we are running out of the time. I know we started a little bit late, but please
Yes,
cover your presentation within 2 minutes, please.
2 minutes, yes.
Yeah.
So the result, physical parameters of groundwater is donc the temperature is like this picture who you found in your screen. Conductivity, you have the result 6.5 and width 0.5. You have the result of chloride and nitrate, calcium, magnesium, and other hardness. Donc, as a conclusion, we say overall the groundwater quality in the Agadez region show a mixed pattern of compliance with WHO standards. Most parameters remain within acceptable limits, indicating generally good water quality in many locations. However, localized contamination is evident, particularly for nitrate, fluoride, conductivity, and turbidity in specific communes. These variations are mainly influenced by natural geological factors, evaporitic formation, carbonate dissolution, and anthropogenic activities such as agriculture, livestock farming, and inadequate sanitation practice. The result highlights the vulnerability of groundwater resources is arid and semi-arid environment. and emphasize the need for regular monitoring and sustainable management strategies to protect drinking water quality in the region. So, thank you for your attention.
Thank you very much for your attendance. If there is any question we can get, we have a very limited time, but still we have time. Please go ahead.
Thank you, Professor. Thank you.
Thank you. Okay, there is no any question, so we can move to the other presentation. The first presenter is here, I guess, right? Hassan? Assessment
Evet,
of
Maman.
the soil contamination by trace metal elements from wastewater generated during the tank truck gouging operation, a case study at the Bureau of the Mines and Geology of Burkina Faso. By the way, your outfit looks great. I like to have something like similar to your dress. It looks really nice.
Thank you. Do you see my presentation?
Yes, we see you and
Thank
your
you.
presentation and your nice outfits. Very good.
Thank you. Thank you. My name is Abdourazakou Maman Hassan. I am Associate Professor of School of Mine Industry and Geology of Niamey. The topic of my presentation is assessment of soil contamination by trace metal elements from wastewater generated during tank truck gouging operations, a case study of the Bureau of Mines and Geology of Burkina Faso. The outline of my work includes introductions, material and the method, result and discussions, and conclusion. As introductions, we can say environmental contamination caused by hydrocarbon and heavy metal has become a major global concern due to its long-term effect on ecosystem, water resource, and the human health. Industrial and the transport-related activities frequently generate oil, wastewater, and the toxic residues that can accumulate in soil and groundwater. Because heavy metals are persistent and non-biodegradable, contaminated soils might act as long-term pollution reservoirs and pathways for the transfer of contaminants into the food chains. In Burkina Faso, the rapid expansion of industrial and mining activities has increased the risk of environmental pollution associated with hydrocarbon handling, with hydrocarbon excuse me. In Burkina Faso, the rapid expansion of industrial and mining activity has increased the risk of environmental pollution associated with hydrocarbon handling, transport, and storage. Tanker truck gouging operations which involve the measurement and the control of transported liquids might generate contaminated wastewater and accidental spills capable of infiltrating soils and affecting surrounding water resources. Despite the environmental importance of these activities, limited studies have focused on pollution generated by gouging facilities. The Bureau of Mine and Geology of Burkina Faso operates tanker truck gouging infrastructure that play a strategic role in hydrocarbon logistics. However, leaks and wastewater discharge from these operations might contribute to soil and water contamination by grease and trace metal. Evaluating the extent of this contamination is essential for understanding potential environmental impact and identify the sustainable remediation approaches such as phytoremediation for pollution control and the ecosystem restoration. For this work, the study area, like I saw it, the study area conducted at the tanker truck gouging platform of the Bureau of Mine and Geology of Burkina Faso, located in Ouagadougou. The site is dedicated to the volumetric control of truck transporting hydrocarbons and other industrial liquids. The gouging area includes concrete surface, retention basins, and peripheral bar source exposure to wastewater accidental spills and the hydrocarbon residues generated during gouging operation. Due to the repeated circulation and handling of petroleum products, the area is considered vulnerable to soil and water contamination by grease and trace metals. For this rock, we use the digital and non-digital materials. Water and the soil sampling. A preliminary field investigation was carried out to identify representative sampling location based on visible signs of contamination, wastewater accumulation, and the proximity to gouging activities. 3 wastewater samples were collected from retention basins using sterile HDPE bottles and approximately 30 centimeters below the water surface. In addition, 12 soil samples were collected around the gouging platform using a manual auger at depth ranging from 15 and 30 centimeters. Sampling points were distributed between highly impacted zones near the basin and the peripheral zones located further from the discharge areas. The laboratory analysis, for this laboratory analysis, water sample were analyzed for total grease concentration. Soil sample were air crucial pulverized and analyzed using portable X-ray fluorescence spectrometry XRF. The analysis trace metal included lead, copper, chromium, cobalt, nickel, zinc, cadmium, arsenic, and mercury. As a result in the discussion, total grease concentration in wastewater. The result revealed important variation in total grease concentration among the analyzed wastewater samples. One sample presented concentration below the detection limit, while another reached 44.8 milligrams per liter. The third sample exceeded the measurable detection limit of the instrument, indicating severe hydrocarbon contamination. The measured concentration in some samples exceeded the commonly accepted discharge threshold for oils and the grease in wastewater, highlighting the environmental vulnerability of the gouging area. Such contamination might contribute to soil degradation, reduced permeability, and the possible groundwater pollution through infiltration processes. The XRF analysis showed variable concentration of heavy metal in soil collected from the gouging platform. Chromium concentration ranged from 146.75 to 260.54 milligram per kilogram. For example, chromium concentration exceeded common soil guideline value in several samples, particularly near area exposed to wastewater accumulation. This suggests possible contamination from petroleum residues and the industrial fluids used during gouging operation. Elevated zinc and lead concentration were also observed in specific sampling points, indicating localized pollutant accumulation associated with repeated hydrocarbon handling and the truck circulation activities. Copper concentration were generally moderate, although one sampling point presented value exceeded recommended soil quality thresholds. The presence of arsenic remained relatively low compared with international guideline values, suggesting limited contamination by this element. Nickel was detected in the
Doctor,
oil.
I am interrupting you. The last 3 minutes, just would like to remind you.
Thank you. Environmental, conclusion, this study revealed significant soil and wastewater contamination at the Bureau of Mine and Geology of Burkina Faso gouging area, mainly by grease, chromium, zinc, and copper and lead. Some concentration exceeded environmental guideline values, indicating the impact of tanker through gouging activities on the local environment. The result suggests potential risk for soils and the groundwater resource. The reduce this impact, improved wastewater management and environmental monitoring are recommended. Phytoremediation using pesticides such as vetiveria zizanoid hilamtu anis, a sustainable and cost-effective solution for the restoration of contaminated soils. Thank you for your attention.
Thank you very much. Any question? If no, I will ask you a question. So, do you think that just by certain, let's say, educational information to the people or who is working on that field or on mining and so on, can help to reduce the amount of the metals in that aspect of the water and the soil and so on? Can you hear me? Doctor, are you there?
I don't think of- Do you hear me?
Yes,
Yes.
now I can hear you.
Do you hear me? Hello?
Now we can hear you.
Hello?
Yes, now we can hear you. Can you hear me?
I don't know, but
Yana jin kari.
Yana jin ka, Razak, yana jin.
No. Can you hear me?
Professor, do you read the question? What was the question?
I asked about the soil contamination. Do you think that even just without any certain precaution, just to inform the people and inform the actually people who working on that area and working in that field, to inform them and to educate them will be enough to decrease the amount of the soil contamination or not?
Tu parles de téléphone, vous voyez,
Et non, Abdourazakou, il parle de la sensibilisation et la communication des gens pour la contamination. Et si je peux tenter de lui répondre en English.
Probably we have a
Il faut parler.
misconnection.
Il faut parler.
Sorry, he has an internet problem. He
Okay.
doesn't hear.
I
What you
realized it. Okay, so let me invite the third presenter. We have to move on meanwhile, because people are waiting. All of the authors and the audience are looking forward to hear the next presentation. So the third presentation of this session is going to be presented by Diane, Lydie, Hounkpe, Laurent. Review of mining activities in Niger and rehabilitation methods. Are you there, Diane?
Yes, I'm here.
Okay, welcome.
Can you hear me?
Yes, we can
Yes.
hear you. We cannot see
Okay,
you
my video
neither
has a
your
problem. I don't
presentation.
know. Okay. Please, can he disconnect his presentation?
The technical desk is going to help you about that issue.
Yes. Okay. Can you see my presentation?
Now we can see your presentation. Do you have camera? And if possible, so if you have internet problem and difficulties about turning on your cam, it's not a problem. But if you have a camera, we would love to see you as well. As I said, still it's up to you, but if possible.
I'm trying to open it, but I don't know what's happened.
Okay, no problem. Continue with your presentation. Please
Okay.
introduce yourself and then continue.
Thank you, sir. I'm Diane Lydie Hounkpe from University of Danklodo, of Niger here in Maradi. Excuse me, can you give me just 1 minute
Of
to
course, sure.
give a tribute to Dr. Ibrahim Wagani? He is the first person that his name is read here in our presentation, but we are sorry to announce that he has passed away
Ah, sorry.
24 of March.
Sorry.
So he
Sorry.
was
So sorry for your loss. I wish him the best. God bless him. Inshallah, is in Jannat, is in Eden.
thank you. Amen. Amen. He was a professor here, an associated professor, and dean of the Faculty of Sciences. His sudden passing has deep affect a renowned professor, and as my supervisor, he was a source of inspiration. He was a very good person. We are shocked that it happened, and so may his soul rest in peace.
Yeah.
For our work, we have as planned introduction, we have to present some mineral resources of Niger, the ore mining operation and beneficiation, the environmental impacts, and the literature review, and the end will be the rehabilitation solutions. Mining activities plays an important role in the global economy. Here in the Republic of Niger, possessing significant mineral resources, we have a lot of mineral resources because of geological structure contain Precambrian basement formation that outcrop in Litako, Air, Damagaram Muniu, and South Maraji. The extractive industry sector has developed over several decades with the load of uranium mine in northern Niger. There has also been coal and gold mining in the eastern part of the country. However, the mining sector is subject to some important changes. Some large mines have reached in the phase of closure. Artisanal gold mining is receiving increasing attention due to its environmental and social impacts in the context marked by insecurity. Here we have a map which shows us the minerals that we can find here in Niger. We have on the western border of the Ai Massif, the mining sites in exploitation are the Alit site, the Akuta site, and the Azlik site, respectively exploited by Soumaïr, Cominac, and CNNC. So in Niger, there are 9 mineral resources such as uranium, gold, oil, coal, critical minerals, and others, and untapped potential. We have also Liptako gold mine in order to increase national economic benefits. Gold mining is an important sector, generating income for a large number of workers, such as digger, mechanics, restaurant workers, transport. And it's almost impossible to ban or stop it in practice. Therefore, it's better to regulate it and mitigate its potential impacts. Ore mining operation and beneficiation. Here on this map, we have the waste that the mine exploitation can provide. So mining waste as waste rocks, processing waste as tailings, metallurgical waste as slags. There are different forms of mining, and each varying according to its objective and methods. In carriers, the extracted minerals are construction materials, whereas in mines, they are materials for industry. We have open pit mine, which are used to extract minerals that occur naturally near the earth's surface. So we have 2 examples on those images. Examples of open pit mine. We have also underground mine, which allow the extraction of minerals buried deep beneath the earth surface. So here we have an entrance of the underground mine. And here we are someone inside the mine, the underground mine. So here in Niger, uranium is the most mineral that is exploited. So we have here, so the first step is to storage uranium. What will happen? It will be treated into granulometrical treatment that will provide crushing and after to be grading. The second treatment is a chemical treatment that will necessitate the use of acids. And after, finally, we'll have the mineral that will be extracted. Environmental impacts. Unfortunately, just like most human activities in their environment, communities and environments in mining areas are highly vulnerable to the harmful effects of mining company activities. So mining industries typically release toxic waste. So we can see here two sources of heavy metal, the anthropogenic sources and the natural sources. We know that environmental impact of mining ore can affect a lot of things, such as the water resources. In water resources, for example, in case of sulfide waste, its interaction with air and water leads to environmental pollution, more especially known as acid mine drainage. We can see here the impacts of acid mine drainage that can affect the environment, and it's very, very difficult to remove it. The mine ore extraction can also influence the social economic situation or activities. We have three types of social economic perspective that we can mention. Look, impacts on local communities, working conditions, and relation with indigenous people. The most important source of air pollution in mining operation are mobile sources, stationary sources, and fugitive emissions. So to remove that pollution that's caused by mining exploitation, we have the rehabilitation. Mining practices often employ unsustainable methods and processes, leading to soil degradation and chemical pollution. To mitigate these impacts, rehabilitation plans must be implemented before mining operations begin. Rehabilitation employs various techniques as desulfurization, precipitation, the barrier method, seed revegetation, phytoremediation, and more. These methods aim to restore seeds to a state of as close as possible to their previous states. The methods of rehabilitation, we can see some of them, like conventional treatment for remediating soil contaminated by organic compound are primarily based on chemical methods. We have containment that is more a solution than a pollution control method. So for containment, we have it can be applied using three methodologies: surface containment with the installation of geomembrane, the vertical confinement behind earth walls made of concrete retention materials of plastic mortars, and finally the deep horizontal confinement. We have another method of rehabilitation, which is encapsulation, which consists of a containment cell for the ore tailings to isolate them and prevent pollutants from entering the environment through the pathway transfer. We have another method of rehabilitation, which is the phytoremediation technique. This is the using of plant experts to remove the radioactivities or the polluant from a soil. So here we have some example of the plant species that can be used. We have Acacia mangium, Cassia siamea, Eucalyptus macaldulensis, or Peltophorum pterocarpum. So for a rehabilitation, we have to identify and evaluate the damaged mining areas. If I take an example, if soils are degradation, we can use the phytoremediation and the vegetation will recover the soil. If we have the slope instability, we can use the slope stabilization and erosion will be controlled. If we have vegetation loss, we can use the soil rehabilitation and slope will be stabilized. If it's a water accumulation, so water area will be management and pollution can be reduced. Niger has a significant mining potential. However, mining operations must employ best practices to mitigate their environmental impacts. Strict regulation must be developed and implemented, and advanced technologies for waste management and water treatment must be used. Reduction environmental impacts in the short and long term requires a rehabilitation plan tailored to each mine. It is therefore essential to draw up this plan well before starting the mining operation. Thank you for your attention.
Thank you very much, Diane. Any question? Please. Diane, I am very, very sorry for your loss, and I wish him the best, and hopefully may God let his soul rest in peace. I don't know, probably you
Professor.
mentioned that he passed away suddenly and unexpectedly, right? He was not sick, I guess, right?
Yes, he was my advisor, and we were at Arlit for taking the echantions. So when we come back, he passed away the same day.
During the, okay, it was kind of heart attack or something else?
We don't know. They just remark that he come, but he don't go outside. So they go into his bedroom, and he was there like he was sleeping, but he was dead. We don't know what's happened exactly.
So sorry once again, and thank you very
Thank you,
much for the
Professor.
nice presentation. And this is dedicated to his memorial, and I hope that it's a nice gift to him as well.
Thank you, sir.
Professor. Thank you, sir.
Well, I'm really sorry. Okay, so if there is no any other question or any comment is welcome as well, because yes, we are doing science, we are dealing with science, but still we are human being and we have to share our emotions as well. We are not, thanks to God, robots without any kind of emotion. Thanks to God, we have emotion. Thanks to God, we have soul. Thanks to God, we have some feeling to understand each other. That's why
Thank
I would like to mention once again, not like a semi-human telling, okay, sorry, go ahead. No, I felt really sorry.
Thank you, Professor. Thank you so much.
Okay. Now let's continue with the next presenter. I think is here, right? Probably we are going to continue with the fourth presenter, prospective study of the neutralizing capacity of the dolomite on acid mine drainage, application on the tailing of the Perkin mine in Burkina Faso. And now Dr. Abdourazakou Maman Hassan is going to present, right?
Yes. Excuse me, you. Sorry, I had an internet connection problem. Regarding your question during my first presentation, I can say the awareness activities are regularly carried out for the local population. In parallel, we have suggested the planting of certain plant species. As a precautionary measure, workers are also sensitized to avoid discharging wastewater into the environment. It is what we do about my first presentation. Now I am going to do the second presentation, which topic is neutralizing capacity of dolomite and acid mine drainage application to the tailing of the Percoa mine, Burkina Faso, Niger.
Thank you very much. Please convert to the presenter view.
Thank you. Do you see my screen?
I see all of it. If you can.
The outline. Thank you. The outline of my presentation includes introduction, material, and the method, result, and discussion, and the conclusion. As introduction, context, and the problem assessment, acid mine drainage. Acid mine drainage is generated when sulfide minerals in mine tiling are exposed to water and oxygen, producing highly acidic leachates that threaten surrounding ecosystems and the groundwater quality. The Percoa mine, Central West Burkina Faso, produces zinc-rich tiling with significant AMD generation potential. Research objective: characterize tiling, determine physicochemical and mineralogical properties of Percoa mine tiling, and predict AMD generation via static tests. 2. Analyze Tiara dolomite. Assess the mineralogical purity and the chemical composition of Tiara dolomite as a neutralizing agent. 3rd, evaluate neutralization. Conduct 23-day column leaching experiment to quantify dolomite's effectiveness in neutralizing AMD acidity. As material and the method, the study was conducted at the Percoa mine, Burkina Faso, one of the West Africa's largest zinc mines located in the Central West region. 4 tiling samples were collected representing distinct geochemical zones of the storage facility. Tiara dolomite in the Haute basins. Local carbonate rock used as alkaline amendment subjected to mineralogical, chemical, and physical analysis prior to column testing. You use and material used in the field and laboratory in this picture. Digital equipment was also used as methodology for characterization, mineralogical and chemical analysis of dolomite and tiling, static tests, AP and CNP measurement to assess reactivity. Column step: 60 cm head columns assembled for flow tests. Neutralization: 23-day experiment with acidic tailing per column. This integrated approach combines laboratory geochemical characterization with dynamic column testing to provide a robust prospective assessment of dolomite's neutralization performance. As a result and the discussions, dolomite mineralogical and the chemical profile. Analysis of table above shows that the dolomite sample contains 60.1% dolomite, 9.4% calcite, and 8.8% quartz. It also reveals the presence of secondary minerals such as lizardite, vermiculite, and talc. Analysis of the dolomite reveals a chemical composition rich in calcium and magnesium, making this material particularly suitable for the treatment of acidic leachate. Metals such as cobalt, lead, nickel, beryllium, zinc, and chromium are also present in very small quantities. The very high calcium and magnesium values in the dolomite compared to other elements reflects its purity as calcium carbonate, and particularly regarding its use for the remediation of water contaminated with heavy metals. Chemical composition analysis of the dolomite reveals a chemical composition rich in calcium and magnesium, making this material particularly suitable for the treatment of acidic leachate. Metals such as cobalt, lead, nickel, beryllium, zinc, and chromium are also present in very small quantities. Secondary minerals include lizardite, vermiculite, and talc. Trace metals detected are very low, non-critical concentration. Acidification potential against carbon neutralization potential. Static geochemical tests on each tailing sample were easy to classify. IMD generation lifts. AP quantifies the acid production potential of sulfide mineral, while CNP measures the buffering capacity of carbonate phases. Average pH rose from strongly acid to near neutral over from 2.730 microsiemens centimeter to 1,592 microsiemens centimeter, significant ionic lead reduction. OLP reduction potential fell from 681.61 millivolt to just 2.6 millivolt, indicating strong chemical attenuation. Discussion: how dolomite neutralizes AMD? Dolomite dissolves in acidic condition, releasing calcium and magnesium ions that consume proton, raising pH and precipitating dissolved metal. The dramatic ORP decrease confirms the separation of oxidizing condition that drive sulfide mineral watering. As conclusion and perspective, this work confirms effectiveness. Terra dolomite significantly neutralizes AMD from percoa tiling, raising pH from 3 to 6.6 within 23 days. Environmental relevance: a locally sourced, cost-effective passive treatment solution applicable to West African mining context. Future research: long-term field scale trials, optimization of dolomite dosage, and assessment of effluent metal compliant with environmental standards are recommended. Thank you for your careful attention.
Thank you very much, Doctor, for the impressive, insightful presentation. If there is any question rising in your mind, please go ahead to ask Dr. Hassan.
Thank you, and thank you. It is almost time to pray here.
You're welcome.
Yes.
Tu peux parler français, je que passe.
Oui. Il est presque l'heure de la prière ici, donc d'être un peu rapide. On n'a que 10 minutes pour aller à la mosquée.
Comme ci, comme ça.
Bon,
Je peux parler français un petit peu.
Oui. Vous pouvez parler, je vous écoute.
Evet, başka sorusu olan veya sorusu olan arkadaşımız var mı? Yoksa, if there is no any other question, this is as all of you know, it's a bilingual symposium. We carry out our session both in Turkish and in English mainly. So if there is no any question, I will continue with the next presenter. But the point is that the presenter is going to join us from Nigeria. He tried to join us several times. He couldn't join us. Now is he with us? I don't know. Dear Dr. Hassan, can you turn off your microphone, please? And I would like to all of you stay here in the room. Well, the next presenter is joining us from Nigeria. He has the problem about the connection. That's why he sent the presentation to me. Let me try to put the presentation on behalf of him. So with that last presentation, we will complete this session completely in a good way. And all of the presenters are here. Let me present the next one. I am trying to reach out the author again. I will host you for a couple of minutes, not too much, for 2 minutes or 3 minutes. Please keep your patience and be with us, because at the end we are going to take a picture. So please be with us. Okay, dear all, thank you very much for being with us. Now I am going to put the presentation of the author. He sent it me through the WhatsApp, but his connection is very poor. He cannot connect. I am one of the co-author as well. That's why it's not so big deal. I am just asking the technical desk to let me share the presentation, if possible, so please. I will just at least present on behalf of him until he joined us. Still, it's completely acceptable because I am the co-author as well. Dr. Sümeyye Sınır, are you there? Can you hear me?
Buradayım hocam. Şimdi bakıyorum. Ee,
Paylaşma iznim var mı benim?
ben Tekrar bir şey yapar mısınız hocam?
Şimdi
Paylaş.
oldu mu?
Evet, varmış.
Oldu mu?
Evet, şu anda oldu hocam.
Tamam.
Ben de
Okay, now I would like to present this presentation on behalf of the Ömer Faruk Al Mustafa. As I said, supposed to be presented by him, but since he's joining us from the Nigeria, he just barely writing down that he don't have any kind of internet access, even receiving such WhatsApp taking more than 5 minutes or 10 minutes. So it's really difficult. Now, if you can hear me, it's okay. Studies on the impact of the pH on the color properties of the aqueous dyes. As you can see, presenter Ömer Faruk Al Mustafa, Department of the Industrial Chemistry, Faculty of the Physical Science, Federal University of the Katsina State, Nigeria. This is the introduction. The chemistry of dyes and their interaction with aqueous media has remained an area of the great interest within the industrial chemistry due to its broad application in textiles, food, cosmetic, paper production, and pharmaceuticals. Dyes are complex organic compounds capable of imparting color to the substrate by selective absorption of visible light, and their application depends on stability, intensity, and fastness of the color under varying conditions. Among the factors that significantly influence dye behavior in solution, pH occupies a central position, as it directly affects the molecular structure, ionization state, solubility, and ultimately the perceived color of the dye molecules is important. Statement of the problem. The application of dyes in industrial and laboratory setting is critically influenced by the chemical environment in which the dyes are used, with pH being one of the most significant factors affecting their performance. In aqueous solution, dyes undergo structural and electronic modifications in response to the change in hydrogen ion concentration. These modifications often manifest as variation in color intensity, hue, and stability, which can have profound implication for industrial process and product quality. Despite the wealth of research on dye chemistry globally, there remains a limited understanding of the quantitative and qualitative impact of the pH on the performance of both synthetic and natural dyes in the Nigerian industrial context. So what is the aim of the study? The aim of this study is to investigate the impact of the pH on the color properties and UV visible absorbance of the aqueous natural dyes extracted from hibiscus and turmeric, which is Curcuma longa, and Hibiscus subdarifa, with a view of evaluating their potential as natural pH indicators, and the objective, extract the natural dyes from hibiscus and turmeric using the suitable aqueous extraction methods, prepare the dye solution at different pH levels, such as the fact that pH 2, 4, 7, 10, and 12, and observing and recording the color change of the dyes at varying pH conditions. The study of the impact of the pH on the color properties of aqueous dyes is a substantial academic, industrial, and environmental importance. From an academic perspective, this research contributes to a deeper understanding of the dye chemistry, particularly regarding the interaction of dye molecules with hydrogen ions in aqueous media. While several studies have explored dye behavior in controlled laboratory settings, there remains limited systematic research that examines the comparative responses of both natural and synthetic dyes to varying pH conditions within the Nigerian context. The finding of this study will provide empirical data that can serve as a reference for researchers, chemists, and educators seeking to understand colorimetric changes in dyes and the underlying chemical mechanism. As a material methods, you can see 100 milliliter and 250 milliliter beakers, measuring cylinders, volumetric flasks, test tubes, funnels, filter papers, pH meter, pH indicators, and UV visible spectrophotometer being used. Preparation of the natural dyes has been carried out with two main sources. The first one, hibiscus dye extract. The second one is the turmeric dye extract. And for hibiscus, 10 gram of the hibiscus pellet being weighted, added at 100 milliliter distilled water, heated until 60 to 70 Celsius degree for 10 minutes, cooled and filtered and labeled. Similarly, turmeric dye extract being prepared with the addition of the ethanol distilled water mixture, 50% by volume, and stir for 10 minutes. That's all. So, following it, preparation of the acid and the bases, 8.3 milliliter concentrated hydrochloric acid diluted to 1000 milliliter with distilled water, and 0.1 molar of the sodium hydroxide has been prepared by weighting of the 4 gram of sodium hydroxide pellets, dissolved and make it to the 1000 milliliter with distilled water. For each dye extract, pipette of the 10 milliliter been used and the 5 test tubes and labeled as a pH 2, 4, 7, 10, and 12. Adjusting the pH has been carried out by using the hydrochloric acid and the sodium hydroxide, and the result represent that hibiscus dye absorbance at 520 nanometer, and when pH 2, the absorbance is 1.245. When pH 2, it's 1.080. When pH 7, as you can see, the absorbance is decreased by increasing number of the pH. When we increase the pH, the absorbance decreased. Showing the UV visible spectra of the analysis of the hibiscus, here you can see the absorbance and the pH. Result showing the effect of the pH on the color properties of turmeric dye. For pH 2 is yellow, 4 yellow, 7 yellow. At pH 10 it's orange reddish, and at 12 is reddish brown. Here this is the result of the turmeric dye, and you can see, and this is other result of the turmeric dye absorbance at 424 nanometer. The absorbance is increasing, slightly increasing actually with the pH. Conclusion, this study demonstrates that pH is not merely an external variable, but a fundamental determination of the chemical structure and visual performance of aqueous dyes. Through the experimental analysis of the hibiscus subdarifa and curcuma longa, we have observed how shifts in hydrogen ion concentration trigger the structural transformation in chromophores, and specifically the fluoranium cation in hibiscus and the deprotonated enolate form in turmeric. These are the references. Finally, I would like to thank you for listening, and I would like to thank to Umer and Yasir Al-Bashir for carrying out the research and preparing the presentation. And I would like to thank all of you for listening. If there is any question, please let me know. I think there is no question. I thank to myself as well. Okay, now it's time to completing this session successfully and by full attendance. We completed this session. Thank you very much for being with us. Thank you very much for giving us to have opportunity to listen your presentation and your research. It was a great honor and great pleasure to have you here in our institution under this 10th International Student Science Symposium. We look forward to see you in upcoming International Student Science Symposium next year. Thank you. Now, I would like to ask you, if possible, please turn on your camera and let's have a screenshot as a memory of today all together. If possible, if you turn on your camera, I will appreciate, I will be glad. Okay. Diane, Hassan, Dr. Hassan, are you there? Maybe. Diane, do you have camera? Okay.
The same problem continues. I can't open it.
Okay. Anyway, Dr. Hassan. Anyway, technical desk, please, can you take our picture as a memory of today? I think it's done. Thank you very much for attendance. Have a nice afternoon.
Teşekkürler hocam.
Biz teşekkür ederiz. Hepinize iyi
Teşekkürler hocam.